Welcome to the deep dive. Today, we're going on a mission to understand Earth's atmosphere,
Okay.
that invisible force that makes our planet livable.
Right.
We'll be using a stack of educational slideshows aimed at different age groups, which is actually pretty cool because it gives us both basic explanations and some surprisingly complex details.
Hmm.
By the end of this deep dive, you'll understand how the atmosphere works, why it matters,
Right.
and maybe even have some new facts to impress your friends.
I love how these slideshows use different approaches to explain the atmosphere.
Yeah.
It really highlights how something can be simple and incredibly complex at the same time.
Okay, so first things first.
Okay.
What is the atmosphere? I know we've all heard the term, but do we really get what it is?
It's easy to think of it as just empty space,
Right.
but it's actually far from empty. The atmosphere is a dynamic mixture of gases, primarily nitrogen and oxygen, acting like a giant blanket wrapped around our planet.
Oh, okay.
And get this, it's not just static. It's constantly in motion, interacting with Earth's surface and responding to various forces.
That blanket analogy is a good one.
Yeah.
And one of the slideshows mentions how this blanket is held in place by gravity, right?
Exactly. Gravity pulls everything towards Earth's center,
Mm-hmm.
including air molecules.
Right.
The closer to the surface, the stronger the pull, which is why air is denser down here where we live.
That makes sense. But isn't the Earth also rotating?
Yeah.
Does that affect how the atmosphere behaves?
You're right, the Earth's rotation does play a role.
Okay.
It causes something called the Coriolis effect, which influences wind patterns and weather systems.
Okay.
Think of it like this. As the Earth spins, air moving from the poles toward the equator gets deflected to the east, creating those prevailing winds we learn about in school.
Wow, so gravity and rotation are shaping how our atmosphere works. That's
Yeah.
pretty cool. But speaking of gravity, the slideshows use some interesting images to show how its pull affects air pressure.
Uh-huh.
There's an astronaut practically floating in space, a ninja standing on a mountain peak, and a regular guy just chilling at sea level.
Those images are a great way to visualize how gravity affects air pressure.
Oh.
Remember, air pressure is simply the weight of all those air molecules pressing down on us.
Right.
The higher you go, the fewer air molecules there are above you, so the pressure decreases.
So that's why it's harder to breathe on top of Mount Everest than it is at, say, the beach.
Exactly.
There's literally less air pushing on you.
Precisely. And it's not just about breathing.
Okay.
Air pressure affects a lot of things, from how airplanes fly to the way weather systems develop.
Speaking of those slideshows, one of them uses a cool analogy to explain air density.
Okay.
It shows two containers, one packed with molecules and the other more spread out.
That's a great way to visualize air density, which is how closely packed those air molecules are. Because of gravity, the denser air is closer to the surface.
Okay.
As you go higher, the air thins out, and those molecules have more space to bounce around.
Okay, so gravity pulls the molecules closer together, creating denser air near the surface. That makes sense. And thinking back to that image of the hiker on the mountains struggling to breathe, is that because the air is less dense up there?
Exactly. Less dense air means less oxygen packed into each breath, which is why it can feel harder to breathe at higher altitudes.
Right.
Athletes often train at high altitudes to increase their red blood cell count, which helps their bodies use oxygen more efficiently.
Wow, that's fascinating. It's amazing how something as simple as air density can have such a profound effect on our bodies.
Yeah.
But so far, we've mostly talked about air pressure and density. What about temperature?
Well, air temperature is essentially a measure of how fast those air molecules are moving.
Okay.
The faster they move, the more heat they generate, and the warmer it feels. Remember those diagrams in the slideshows showing air molecules at different energy levels?
Yeah, the ones where the molecules are bouncing around like crazy at lower altitudes where it's warmer.
Right.
So does that mean temperature, like air pressure and density,
Yeah.
also decreases with altitude?
Generally, yes.
Okay.
With fewer molecules at higher altitudes, there are fewer collisions to generate heat, so the temperature tends to be lower.
Okay.
That's why those mountaintops are often snow-capped, even in summer.
Okay.
But there's a twist. Remember how we talked about the Earth's rotation and the Coriolis effect?
Right.
Well, those atmospheric layers we're going to explore soon. Their temperatures don't always follow. A simple gets colder as you go up pattern because of how they interact with solar radiation and those atmospheric winds.
Okay, you've definitely piqued my curiosity. I'm ready to take a grand tour of those layers, as one of the slideshows puts it.
Okay.
But before we blast off, maybe we can connect all this back to our listener for a moment.
Okay.
Why should they care about air pressure, density, and temperature?
Yeah.
It can feel kind of abstract sometimes.
You're right. It's important to bring it back down to earth, so to speak.
Yeah.
Think about it. Air pressure affects our breathing.
Uh-huh.
Air density influences how airplanes fly.
Yeah.
And temperature. Well, temperature is something we experience every day, from the warmth of the sun on our skin to the chill of a winter breeze.
That's a good point. It's easy to forget that the atmosphere isn't just this thing out there.
Yeah.
It's intimately connected to our lives in countless ways.
Exactly.
Okay, I'm officially ready for that grand tour.
All right, let's ascend through the atmosphere, starting with the layer we're most familiar with, the troposphere.
Okay.
This is where weather happens, clouds form, and life as we know it thrives.
It's like the ground floor of the atmosphere where all the action is. One of the slideshows mentions that the troposphere is actually where most air pollution gets trapped too, which is kind of a bummer.
That's right. Pollution from cars, factories, and other sources can accumulate in the troposphere, leading to smog and other air quality issues.
Right.
But let's not dwell on the negative.
Okay.
Let's continue our ascent.
Next stop, the stratosphere. Home to the ozone layer, right. One of the slideshows described it as Earth's sunscreen, which is a pretty awesome analogy.
It is. The ozone layer absorbs most of the sun's harmful UV radiation, protecting life on Earth.
Right.
Interestingly, temperatures actually increase as you go higher in the stratosphere, unlike in the troposphere. That's because the ozone layer is absorbing all that UV radiation, converting it to heat.
So it's getting warmer as we go UP. That's definitely different from what I expected.
Yeah.
What's next on our atmospheric tour?
Above the stratosphere lies the mesosphere, a layer where temperatures plummet once again.
Okay.
This is where most meteors brun up upon entry, creating those dazzling shooting stars we see in the night sky.
It's amazing to think that something as small as a meteor can create such a brilliant light show.
It's a testament to the incredible energy involved. The friction generated by those meteors colliding with air molecules in the mesosphere creates enough heat to vaporize them.
Wow.
Talk about a dramatic entrance.
Okay, 2 layers down, a few more to go. What's next on our ascent?
As we climb higher, we enter the thermosphere.
Okay.
This layer, though incredibly hot, is also surprisingly thin. In fact, the air molecules are so spread out that they rarely collide. So it wouldn't actually feel hot if you were up there.
That's kind of counterintuitive. I always imagine space as being incredibly hot.
Yeah.
But it sounds like it's more about the energy of the sun's radiation than the actual temperature.
You're right. It's more about the intensity of solar radiation.
Okay.
And speaking of space, that brings us to the final layer of our atmospheric tour, the exosphere.
Okay.
This is the outermost frontier of the atmosphere, gradually fading into the vast emptiness of space.
It's like the final frontier of our planet's atmosphere, the boundary between Earth and the cosmos.
Right.
It's pretty mind-blowing to think about how something as seemingly simple as air can extend so far out into space.
It really highlights the incredible scale and interconnectedness of everything in our universe.
Yeah.
But remember, even though we've talked about these layers as distinct entities,
Right.
in reality, the boundaries between them are gradual. There's a lot of interplay between them.
That makes sense. It's not like there's a giant wall separating the troposphere from the stratosphere.
Right.
It's more like a gradient, a gradual transition.
Exactly. And all of these layers work together to create this complex and dynamic system that we call the atmosphere.
This grand tour has been incredible, but you mentioned that the boundaries between these layers are gradual.
Yeah.
And there's a lot of interaction between them.
Right.
Does that mean there are variations within each layer?
You're thinking along the right lines. Remember how we talked about the Coriolis effect and how it creates those prevailing winds?
Yeah.
Well, those winds, along with other factors like temperature differences and the distribution of land and water masses, can create some pretty fascinating variations in each atmospheric layer.
So it's not just about altitude then.
Right.
There's more to it than just higher equals colder and thinner. It sounds like the atmosphere is more like a giant, constantly shifting puzzle.
You're getting it.
Yeah.
And one of the most interesting examples of this is the concept of microclimates. Remember those images in the slideshows showing how mountains and valleys can create their own unique weather patterns?
Yeah, those were cool. They showed how a mountain range can block moist air from reaching one side,
Right.
creating a rain shadow and a much drier climate.
Exactly. And those are just a few examples. Think about how living near the coast might create a different microclimate than living in a desert.
Right.
Or how a city with all its concrete and buildings
Yeah.
might have a different microclimate than a forested area.
It's like each location on Earth has its own little atmospheric personality.
That's a great way to put it.
Yeah.
And those microclimates can have a big impact on the types of plants and animals that can thrive in a particular area.
Wow. So we've gone from this big picture view of atmospheric layers to these smaller, more localized variations.
Right.
It's amazing how something as seemingly vast and uniform as the atmosphere can also be so incredibly diverse and complex.
It really is. And it's a reminder that there's always more to learn, even about something as familiar as the air we breathe.
That's a perfect place to wrap up part one of our deep dive. We've explored the basic properties of air, taken a grand tour of those atmospheric layers, and even touched on the fascinating world of microclimates. But our exploration of the atmosphere is far from over.
Stay tuned for part 2, where we'll delve deeper into the composition of the atmosphere, explore the impact of human activities, and unravel some of the mysteries of those incredible atmospheric phenomena we've all wondered about.
Welcome back to the deep dive. Last time we took a whirlwind tour of Earth's atmosphere, from the bustling troposphere to the edge of space and the exosphere.
We even touched on those fascinating microclimates,
I did.
those little pockets of unique atmospheric conditions shaped by local geography and all those interacting forces we talked about.
Right. It's mind-blowing how much variation there is within something as seemingly vast and uniform as the atmosphere.
Yeah.
But today, we're going to zoom in even closer and explore what the atmosphere is actually made of.
Yeah, it's more than just nitrogen and oxygen up there. We're going to delve into the fascinating world of trace gases and even those tiny particles that are floating around up
Wait,
with.
there are solid particles in the atmosphere. Like what, dust? Pollen?
You got it. There's all sorts of stuff floating around up there. Dust, pollen, volcanic ash, sea salt, you name it. And while these particles might seem insignificant, they actually play a surprisingly important role in atmospheric processes.
Okay, I'm intrigued. But before we get into those tiny particles, let's talk about those trace gases you mentioned.
Okay.
One of the slideshows mentioned carbon dioxide, and I know that's a big deal when it comes to climate change.
You're right. Carbon dioxide is a major player in the climate change conversation.
Yeah.
It's a greenhouse gas, which means it traps heat from the sun.
Okay.
And while we need some greenhouse gases to keep our planet habitable, too much can lead to a warming effect.
So it's like the atmosphere is wearing a blanket that's getting a little too thick.
That's a good analogy. And human activities like burning fossil fuels release extra carbon dioxide into the atmosphere, making that blanket even thicker. Scientists are concerned about the potential consequences of this warming trend, things like rising sea levels, more extreme weather events, and shifts in ecosystems.
Okay, so carbon dioxide is one trace gas that's getting a lot of attention.
Right.
What about other gases? Are there any others that are causing concern?
There are a few others like methane and nitrous oxide
Right.
that also contribute to the greenhouse effect.
Hmm.
And then there are gases like sulfur dioxide, which is released from volcanic eruptions and industrial processes
Okay.
that can contribute to acid rain.
Acid rain, this sounds pretty nasty.
It can be.
Yeah.
Acid rain can damage forests, lakes, and even buildings.
Yeah.
And it's a reminder that what we put into the atmosphere doesn't just disappear.
Right.
It can have far-reaching consequences.
Speaking of putting things into the atmosphere, one of the slideshows had this crazy picture showing all the different sources of air pollution: cars, factories, power plants, even agricultural activities.
Yeah.
It's kind of overwhelming to think about everything we're pumping into the air.
It's definitely a lot to take in.
Mm-hmm.
And remember how we talked about the troposphere being the layer where most weather occurs?
Right.
Well, it's also where most air pollution gets trapped.
Okay.
This can lead to smog, respiratory problems, and other health issues, especially in densely populated areas.
So it's not just about global warming then. We're also directly impacting the air we breathe.
That's why air quality is such a big concern, especially in urban areas.
Yeah.
It's a reminder that our actions have consequences not just for the planet as a whole,
Mm-hmm.
but for our own health and well-being.
This is getting a bit heavy. I need a mental break. Can we shift gears for a moment and revisit something awe-inspiring like those northern lights we talked about earlier?
Yes. The aurora's a perfect example of the beauty and wonder that the atmosphere can create. One of the slideshows described how these shimmering curtains of light occur when charged particles from the sun interact with Earth's magnetic field.
It's incredible how something happening millions of miles away on the sun can create such a stunning spectacle here on Earth.
Right. Those charged particles excite the atoms in our upper atmosphere, causing them to glow those vibrant colors we see dancing across the sky.
I'd love to see the northern lights in person someday.
Yeah.
It must be an incredible sight.
It truly is. And it's a reminder that the atmosphere is more than just a collection of gases and particles. It's a canvas for some of the most breathtaking displays in nature.
Okay, so we've covered a lot of ground here, from the composition of the atmosphere to the impact of human activities and even those mesmerizing auroras. But
Yeah.
I have a question.
Okay.
We've been talking about the atmosphere as this protective shield,
Yeah.
but are there any aspects of the atmosphere that are, well, a little bit dangerous?
That's a great question. And it's true. While the atmosphere is essential for life, it also presents some inherent risks. Remember how we talked about the mesosphere burning up most meteors?
Yeah, that was wild.
Well, some larger objects can make it through. I'm talking about asteroids.
Yeah.
While those Hollywood disaster movies might be a bit exaggerating,
Yeah.
the threat of asteroid impacts is a real concern.
That's kind of scary. Are scientists doing anything to track those potential threats from space?
Absolutely. There are teams of scientists around the world constantly monitoring near-Earth objects and developing strategies to mitigate potential impacts should a large asteroid ever pose a serious threat to our planet.
That's reassuring, at least. But aside from those cosmic threats, are there any everyday dangers lurking within the atmosphere itself?
Well, the atmosphere itself is constantly in motion.
Right.
Remember how wind is created by differences in air pressure?
Yeah, and one of the slideshows mentioned that high-pressure systems are associated with fair weather,
Right.
while low-pressure systems bring those storms and unsettled weather.
Right. And those pressure differences can sometimes lead to some pretty powerful storms like hurricanes and tornadoes.
Hmm.
And let's not forget about lightning, a dramatic release of electrical energy within the atmosphere.
So it's like the atmosphere is this incredible life-giving force, but it also has a bit of a wild side.
Yeah.
It can unleash some pretty intense forces of nature.
That's a great way to put it. Understanding the atmosphere is about recognizing both its benefits and its potential dangers. It's about appreciating its complexity and respecting its power.
Okay, we've covered a lot of ground in part 2 of our deep dive. We've explored the composition of the atmosphere, delved into the impact of human activities, and even touched on some of those potential hazards, both from space and within the atmosphere itself.
And as we prepare to transition to part 3, we want to leave you with this question. If you could design an instrument to monitor the atmosphere, what would you want it to measure and why? Think about everything we've discussed today, from its composition to those dynamic processes. What information would be most valuable for understanding this crucial layer of our planet?
We'll be back soon to continue our exploration of Earth's atmosphere. Until then, keep those minds curious and those imaginations soaring. Welcome back to the final part of our deep dive into Earth's atmosphere. It's been quite a journey, hasn't it?
It really has. We've explored the atmosphere's structure and composition, its
Yeah.
impact on life, and even some of the potential hazards it presents.
And you left us with that thought-provoking question.
Oh, yeah.
If you could design an instrument to monitor the atmosphere, what would it measure and why? I have to admit, I've been giving that some serious thought.
Me too.
Yeah.
It's a great way to put all this knowledge into action.
Right.
What ideas have you come up with?
Well, I was thinking about all those tiny particles floating around in the atmosphere. What if we had a sensor network that could not only identify those particles, but also track their movements?
That's a brilliant idea. It would be like having a microscopic view of the atmosphere,
Right.
revealing how those particles travel, interact, and ultimately influence things like weather patterns, air quality, and even climate change.
Exactly. We could see how pollution from one part of the world might travel across continents and affect other regions. Or we could study how volcanic eruptions impact the atmosphere on a global scale.
That would be incredible.
Yeah.
It'd be like having a real-time map of the atmosphere's inner workings. What about you? What kind of instrument would you design?
I'm fascinated by those temperature fluctuations between the atmospheric layers.
Okay.
Remember that chart in one of the slideshows?
Yeah.
It showed how temperature rises in the stratosphere because of the ozone layer absorbing UV radiation, then drops again in the mesosphere.
It's like the atmosphere has its own internal thermostat.
Exactly. So I was thinking, what if we had an instrument that could continuously monitor those temperature changes across the globe? We could call it the atmospheric thermometer.
I love it. It would be like having a planetary health check, constantly monitoring the temperature of our atmosphere's layers and giving us early warnings of any unusual shifts or fluctuations.
It would help us understand how those temperature changes are linked to other atmospheric processes like weather patterns and the movement of air masses.
Okay, we've been focused on Earth's atmosphere for this deep dive,
Right.
but it makes you wonder, what about other planets? Do they have atmospheres too?
That's a great question. One of the slideshows mentioned that most planets in our solar system have atmospheres, but they can be wildly different from ours.
Right. Think of Mars, for example.
Okay.
Its atmosphere is incredibly thin, about 100 times thinner than Earth's, and it's mostly carbon dioxide.
So no chance of breathing Martian air then?
Not without some serious technological assistance. But studying the atmospheres of other planets can give us clues about how our own atmosphere evolved.
Hmm.
It can even help us understand the potential for life beyond Earth.
That's a pretty mind-blowing thought. It makes you realize that Earth's atmosphere is just one example, one variation in a vast cosmic tapestry.
It really highlights how precious and unique our atmosphere is what makes Earth habitable, what allows life to thrive on this planet.
So as we wrap up this incredible deep dive into Earth's atmosphere, what's the key takeaway you want our listeners to remember?
For me, it's the realization that the atmosphere is far more than just air. It's a complex dynamic system that's essential for life, full of beauty and wonder, but also vulnerable to our actions.
I couldn't agree more. It's easy to take the atmosphere for granted, but this deep dive has really opened my eyes to its importance.
And I hope it's done the same for our listeners. As we continue to explore and learn more about the atmosphere, it's crucial that we use that knowledge wisely to make informed decisions about how we interact with this vital part of our planet.
We've covered so much ground in this deep dive, from those fundamental properties of air to those breathtaking atmospheric phenomena and even the challenges we face in protecting this incredible life support system.
It's been an amazing journey.
It really has. And to our listeners, keep asking questions, keep exploring, and keep marveling at the wonders of the atmosphere. The more we understand it, the better equipped we'll be to protect it for generations to come. Thanks for joining us on the deep dive.